Hey everybody, and welcome to my video. Today I'm going to talk to you about lightning! Dun dun dun! Sorry about that, where was I? Oh yeah, lightning. Lightning is one of the Earth's greatest natural phenomenons. Many, if not all of us, have witnessed lightning at some point in our lives, so it's something that we should all pretty much be familiar with. But where does it come from? And how does it happen? Is it the strobe lights from an all-night migrating birds dance party? Or possibly simply a group of angels during their cross-dimensional laser tag finals? You know what? We may never know. We may never know. I'll tell you what, though. Let's see if we can test some other people's lightning knowledge skills. And we'll see what kind of shocking answers they have in store for it. Really shocking, guys? Shocking? That's going to be the kind of script that we're going to do with this? All right, you know what? Just go to the interviews, okay? All right, good afternoon, sir. So, what we are doing here today is we are going to do a little bit of a question and answer with you regarding lightning. So, the first question I have for you, we have this handy-dandy device right here, which is going to indicate length on how far you need to be in order to consider yourself safe from a lightning storm. So, on the rope, every little green marker that I've made indicates 1 mile or 2.2 kilometers on how far you need to actually be in order to be safe. So if you would like, you take one end of the rope right here and pull it out as far as you think you need to go in order to be safe from a lightning storm. Then we'll count exactly how many green markers we have.
That's 1 mile for...
1 mile for every green dot. So right now you're at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 miles.
I'll take 10.
10 miles. Okay, very good. All right, we'll stop that right there. All right. Hello, madam. As previously indicated, we're going to be asking some questions about lightning here today. So the very first question that we have for you is, how far do you think you need to be in order to be safe from a lightning strike if you were ever in a storm? So what we have here is our handy-dandy rope device marked with green markers that indicate 1 mile or 2.2 kilometers for every green mark that's on there. So if you would kindly take one end of that rope and extend it as far as you think you need to be in order to be safe from a lightning storm. And we'll see how far you want to go. You can move. I'm not going to move.
I'm trying to find the things.
Yeah.
I don't think you have to be that far away.
So what do you have? You have 1, 2, 3, 4. You're at about 5 miles right now. Keep going or stay. This is your final answer.
Okay, I'll go with 5.
5. Okay. 5 miles it is. Pull out how many miles you approximately think you would need in order to be safe from a bolt of lightning. So how many miles or how many kilometers you would actually need. So you're at 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20 miles. Okay, that's good. 20 miles right there. So, you got 20 miles. Miss, if you don't mind, I'm going to have you do the exact same thing.
Okay, you said it was 3 seconds per kilometer.
3 seconds per kilometer, and 1 mile is approximately 2.2 kilometers.
So 5 seconds per mile? Is that what you said?
5 seconds per mile.
Oh, that's so challenging.
I'm not editing that out. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I'm going to say 10.
Okay, so approximately 10 miles.
Okay.
Fantastic. Okay, so going back to our previous question, how far do you need to be in order to be safe from a lightning bolt strike? We've asked this question to both of you. One of you has indicated approximately 10 miles. The other one has indicated approximately 5 miles. Would you like to know the big reveal answer?
Sure do.
Okay, so with these little green markers indicating a mile for each one, let's see how far we need to go. All right, so I think that just about does it. If we look down at our marker here, that is marker number 50. You actually need to be 50 miles away in order to be safe from a lightning strike. Apparently, a type of lightning called anvil lightning can actually arc away from the storm clouds and strike you at over 50 miles away from the heart of the storm. You would have to be.
Oh no, oh dear.
You guys can both grab onto that rope right there.
Okay.
There you go. You would have to be 50 miles away, over 50 miles away, to be safe actually from a lightning strike. Anvil lightning can strike at over 50 miles away and touch down to the ground. Yeah. All right. Welcome back, eager participants. So, for this next part, I have a very simple question with a very complicated answer, perhaps. How hot is the air directly surrounding a lightning bolt? And to give you a little bit of a reference point here, I put on this video, right on this this board right here, the temperature of the surface of the sun, which is approximately 10,300 degrees Fahrenheit or 5,704 degrees Celsius for those of us who are not in the United States right now. So, with your handy dandy arrow, if you could please indicate how hot do you think the temperature of a lightning bolt would be?
It goes right around here.
Looks like it's 5,000 degrees Fahrenheit. Thank you very much. All right. Well, madam, as previously indicated with our last participant, this part of our game has to do with the temperature of a lightning bolt. So, what I would like you to do, and your question, is how hot is the air directly surrounding a lightning bolt? For a reference point, I have put the sun's temperature, the surface of the sun, on this board, approximately 10,300 degrees Fahrenheit or 5,704 degrees Celsius. So with that amount of knowledge, with your handy dandy little pointer, please indicate where you think the temperature of a lightning bolt would be. Fantastic. 3,000 degrees Fahrenheit. Thank you very much.
I'll say half of
Okay.
the heat of the surface of the
Okay,
sun.
approximately 5,000 degrees Fahrenheit
Yeah.
or 2,500 degrees Celsius, give or take.
Sure.
Something along those lines.
Okay.
All right.
I'll say about 15,000 Fahrenheit.
15,000 Fahrenheit. Okay, very cool. Okay, so the question I asked you before was how hot do you think the temperature surrounding the air of a bolt of lightning would actually be? One of you indicated approximately 5,000 degrees, 5,000 degrees Fahrenheit. The other one indicated about 3,000 degrees Fahrenheit. If you would please unfold that.
Shabam.
The temperature of the air surrounding a lightning bolt is actually about 54,000 degrees Fahrenheit or 29,982 degrees Celsius, which is approximately 5 times more than the temperature of the surface of the sun. With a bolt of lightning, it is actually actually about 5 times hotter than the surface of the sun. Now, the surface of the sun is the coolest part of the sun, keep that in mind, but a bolt of lightning generally goes for somewhere around 54,000 degrees Fahrenheit, where the surface of the sun is only somewhere around 10,000 degrees Fahrenheit. Which was pretty unique. I had absolutely no idea.
Hey, learn something new every day.
So that's what other people have to say about lightning. But what do we know about lightning thus far? Lightning is an electromagnetic current that happens between a positive and negative connection. This electrical current is generally found within storm clouds. Now, this is where the tricky part comes about. We don't know exactly how that electrical charge winds up in the storm clouds. One plausible theory has to do with the water cycle. And for those of you who are not familiar, here's the basics of it. Water's heated up by the sun. It evaporates into the atmosphere. It cools as it rises, forming clouds and condensation, and then enough condensation causes the water to fall back down to Earth as rain or snow. Now, it is at this point right now, during that evaporation and condensation, that you start to get both a positive and negative charge, usually within the clouds. That positive and negative charge tend to separate. Generally, the positive charge goes towards the top portion of the cloud, and the negative charge ends up going down towards the bottom. It's this separation of the charge that you actually need in order to conduct an electric current in between the two. Once the charge is established, all you really need now is basically a path for the current to travel in. Now, lightning can strike in a couple different ways. You can have lightning that strikes in between clouds, lightning that strikes within a cloud, or lightning that strikes from a cloud all the way down to Earth. Essentially, you need that positive and that negative charge. If you have a strong negative charge up in the clouds, you generally are going to have a strong positive charge down on Earth. That charge right there will actually help create a pathway for that lightning to flow. This is also where thunder comes in. Generally, when the lightning starts to go, you generally hear thunder right afterwards. It's because the lightning actually heats up the air so quickly surrounding the bolt of lightning that it creates an audible sound. The air particles actually have to move out of the way so quickly that they make a sound, which now is basically what we call thunder. With such a powerful natural force, lightning has the potential to cause severe damage, whether it be to individuals or even to habitats. Luckily, however, there are some habitats that actually benefit from lightning. It's not all destructive forces. Even when lightning causes fires, there are some plants and some trees that need that fire to help their seeds germinate. So in essence, lightning can actually create new habitats as well. When it comes down to it, many of the misconceptions that surround lightning, or surround anything for that matter, generally have to do with the information that is learned, when it's learned, and how it's learned. Misinformation is sometimes just information that's been passed down throughout the generations that started out as incorrect information and unfortunately stayed that way for a long period of time. But the thing of it is that we learn in all different situations and we learn from different people. So it all really depends on which learning experiences stick with us and which we tend to discard.